So we are going to start off today with talking about 7.1 ratios and proportions. So in this first example, in 2007, the Boston Red Sox team won 96 games out of 162 played. We need to write a ratio for the number of games won. So a couple ways that we can write ratios is x colon y, let's say, or you can do x over y. Okay, you can write it as a fraction. So those are two ways that you can write out your ratios. So taking a look here, it's going to be first, so it's games out of 162 games played. So it will then be 96 colon 162. Okay, so based on how it's written, the 96 would go first. Or we can go ahead and write it as that fraction, so 96 over 162. But you guys, guess what? It's a fraction, which means we have to reduce that. So then we'll get here 16 over 27. So either one would be completely fine. But remember, you have to reduce those. All right, the next one here is the ratio of the measure of the angles in triangle dog. So R2, 3, and then 5 here. So it says find the measures of each of the angles. So we need to find the measure of angle D, measure of angle O, a measure of angle G. Now, based on how this ratio is written, angle D is with the 2. Okay, so it corresponds with that 2. O and 3, and then G and 5. Okay. Alrighty, so taking a look here. We don't know the exact length of those sides just yet, but we can, or sorry, the angles, but we can because we have that ratio. So what we're going to do is we know that the angle D is going to be 2 times some x. And then the measure of angle O is going to be 3 times some x based on the ratio there, and then G is going to be 5 times some x. And we're talking about the angles, right? The measure of angles, so that's 180. So we're going to set that equal to 180 degrees, and we can solve and actually figure out what those angles are. So we're going to get here 10x equals 180, divide by 10, and we're going to get x equals 18. Awesome. Now we need to plug that in. So 2 times, okay, so we're going to plug it in here. So 2 times 18, we are going to get 36 degrees. And then 3 times 18, we are going to get 54 degrees. And then 3 times 18 is going to be 90 degrees. All right, awesome. So there we go. This next one, ready for this tongue twister. Okay, so Mayor Joseph Fitzgerald O'Malley Fitzpatrick O'Donnell, the Edge, Diamond Joe Quimbley Jr. conducted a random survey of 200 Springfield voters and found that 125 approved the job. Okay, if there are, so this is in the same exact kind of pool of the same town. Okay, so let's say that there were 42,000 voters in the town. Okay, predict the total number of voters who approved the job. So when we're setting up these ratios, it's always going to, if it's something like this, we have here the number approved will always be over the total, no matter what it is. So there'll be like some part of it over the total. So then over here, we know that in total, for sure, that we know is 200 voters. 125 of them approved that the job he was doing. We know that if we have here 42,000 voters, but we don't know the total number of voters, okay, who would approve the job he's actually doing, right? Because this is what we're looking for. So this guy here is going to be X. So I'm going to put an X here, okay? So from here, there's a couple different things that you could do. I'm just going to go ahead and actually just cross multiply these. So cross multiply, oops. Oh my goodness. Oh, there's my dogs. Okay, cross multiply this here. And when we cross multiply, we are going to get 125 times 42,000 equals 200x. When we go ahead and solve, we are going to get x to equal 26,250. So this is going to represent the total number of voters who approve the job that he is doing. All right, Next, we have here an example of cross multiplying, just to get that practice in. This unit, we are going to be doing a lot of proportions and cross multiplying and talking about these different equations set up this way. So here, I'm going to highlight the first top and the bottom, the second, and the same over here. This is bugging me. I need to make this bigger. Okay, so I'm going to go ahead, do 3 times 3x plus 1 equals 4 times 2x plus 5. Alrighty, we're going to get 9x. Oh my goodness. We are going to get 3x plus 9 equals 8x plus 20. When we solve, we get x equals 17. Get in the habit of plugging these back in just to double check to make sure that you know it works. So I'm going to go ahead and do some checking over here. So I'm going to check my work. We're going to have here 3 times 17 plus 1 divided by 4. Okay, we're going to have 2 times 17 plus 5 divided by 3. When we go ahead and simplify, that's going to be 52 over 4. Let's see if it's going to equal, to make sure we did this right, 39 over 3. And then that also, both those reduce, and we get 13 equals 13. Beautiful. We know that it works. All right, let's go on to the next page. And 2 similar polygons. Okay, so got to add in some of that geometry now. So here we have a quadrilateral. Okay, we need to list all the pairs of congruent angles and write their proportions that relates to the corresponding sides for that pair of the polygons. So let's go ahead and just do those angles here. Now remember, when we're doing triangles, the corresponding angles were always in that following spot. Like they were just kind of, if we were to highlight how I'm doing right now, this is how we would find that corresponding angle. Okay, it's the same exact thing for a polygon. Okay, so, and notice this keyword here says similar, so they're not congruent, but they are similar, but they're going to have those angles here. So we're going to have angle P is going to be congruent to angle T. Angle Q is congruent to angle U. Angle R is congruent to angle W. Okay, so notice here how these are similar. Similar, when you're talking about triangles or shapes, you're going to have well, I don't do that. Some shape is going to be a squiggle to that shape. Okay, that squiggle is the notation for similar. Okay, so similar, angles are congruent, and sides are not congruent, they are proportional. Okay, so those are the key things here when we're talking about similar polygons, similar shapes. Angles are congruent, sides are proportional. Okay, so now we're going to go ahead and do those sides here. So I'm going to, so we went from, I'm going to just go and circle these P and T, and actually I'm not going to do that. I'm going to go ahead and do those sides. So just as the same as when we did our triangles, PQ, TU. QR, UQ, okay? RS, WX, PS, TX. Okay, so that's going to be that order that we're going to write these in, just like we did when we were talking about our congruent triangles back in that previous chapter from first semester. So we're going to have PQ, segment PQ is proportional to segment TU. And we're going to talk really about what that means and see an example just in a second here. So then we have QR is proportional to VW. We have here RS, WX, and then also PS is proportional to TX. Okay, and so what that means is they're going to have that relationship between the sides. So let's say that we have here PQ is 2, okay, and then TU, let's say then, is 4. Okay, so all I did is I said, okay, 2 I multiplied by another 2 to get to that 4. So then here, SP, let's say that this is 5, or PS is 5, so then TX would be 10 because I took that 5 multiplied by 2. So it's just kind of making our next shape just a little bit bigger, scaling it up a size, okay, or scaling down a size. So here in this example, we're going to go ahead and determine determine if the figure is similar and write a similar statement and the scale factor. Okay, so what I want you to do first is I want you to go ahead and write out the angle pairs and the sides that are proportional to each other before we get started. So go ahead, pause the video, fill this out, and then when you come back, I'm going to have them all down. I went ahead and labeled the angles that are congruent to each other and the sides. So these angles here are all going to be congruent angles, okay? So as you see here, angle P has one arch, and that's the only one that has a single arch. These two have two. I know it's a little hard to see here. This picture is not the best. This one's 3, okay? So as you see here, P is then going to be congruent to itself. Then from there, I went ahead and listed out the sides. So if it's easier to write your similar statement first to then be able to write this step here, go for it. I just went ahead and looked at the triangles individually. So if I go from P to Q, then I know that P to Q would be P to S in the other triangle. So I'm going to go ahead and write that triangle similarity statement. So it's going to be triangle PQR is similar to triangle TST. Notice I did P, then Q, then R, and then P, and then S, and then T. So even if you write just the angles out in this order, just go with that order to write your similar statement. So now we're going to go ahead and write our scale factor. So in that first example, how I said, if we take this as the small shape, let's say, and this is the big shape, okay, if I went ahead and took that one side, I multiplied it by 2, I get 4. If I take the 5, I multiply it by 10. So I'm scaling up the shape, the polygon PQRS to a little bit bigger, to TUWZ, WX. That's kind of what's happening here. So we only know the sides here. So we only know QR and ST, and we know that those are proportional. So I'm going to go ahead and write up that proportion here. So the ratio. Okay, so the scale factor is going to be set up as a ratio, and it's going to be 1 to 2. That's the scale factor, if I can spell that right. Okay, so, and that's where if I said that PR, let's say that PR was 3, okay? So if PR was 3, I know, okay, so if PR is 3, what would PT be, right? So, well, we know the scale factor is 1 to 2, which means this is the small triangle. And then when we get to the big triangle, we're going to multiply all of our sides by 2 to be able to get that. So then we get PT would then be 3 times 2, which would be 6. Okay, so we would get that side to be 6. Okay, so that's where that the scale factor is coming into play. All right, here is this next example. We are given a pair of polygons. They are similar, which is great. What I need from you to do is I'd like you to go ahead and try to solve for x. Now, if you'd like to go ahead and label these, I'm actually going to. So I'm going to say like this, let's say this is A, B, C, and D, and this is going to be E, F, G, and H. I'd like you to go ahead, pause the video, set up your proportions for each polygon, and then we're going to go ahead, your ratios for each polygon, and then we're going to go ahead and solve for x, okay? So I'm going to set up my ratios right now. So go ahead and pause the video, and then when you come back, it'll be done. I went ahead and I wrote out the sides that were proportional to each other, and then I went ahead and wrote what the sides were, right? So AD we know is 12, and then EH is 18, so I set those up in those ratios. Now notice here, we know the first one 100%, which is great. So since we know what that first one is, and we know the second one, we know some stuff from the second one, that third one that I have here, we're missing one of the sides, and then there's a whole side here that we have nothing for. So we're just going to skip over the ones that we don't know things for, because we're just solving for x. So I'm going to go ahead and I'm going to set up our proportions, or set up our ratios as fractions. So I'll have 12 over 18. And then I'm going to set that equal, though, to the other sides here as x plus 1 over 24. So I just set up a proportion of these sides. So now that I have the setup of the proportions of the sides, take a notice. I have here polygon 1 is on the top, and then polygon 2 is on the bottom. It honestly doesn't matter it does matter how you set these up, but as long as you're consistent. So I have the polygon information for the first one on the top and everything from the second on the bottom. As long as you keep it consistent, you'll be fine. To solve for x, so we're going to cross multiply. But to make our life easier, I'm actually going to simplify this fraction here. You don't have to necessarily do this, but I'm going to, just to make our lives so much easier. So I'm actually going to divide both of these by 6. Both by 6, so then we're going to get a 2 over 3 equals x plus 1 over 24. It's just going to make the math a little simpler. So now we're going to get 2 times 24, okay, equals 3 times x plus 1. Okay, when we go ahead and then solve, we're going to go ahead and then solve, and we're going to get to equal 15. So there we go. We are going to be expanding a lot on these proportions and scale factors and writing things out. So if you have questions, please let me know. Send me an email. Your guys' homework for tonight is down here as attached. It'll be in your OneNote. Okay, so a couple of the word problems, setting those up that we did before, a couple cross multiplying. And then here, this one's like example number 2 in the notes, and then a few examples of the last part of the notes. All right, so again, if you have questions, just let me know.